So for this project, I decided to write about phenylketonuria. Hopefully I'm saying that right. I first heard about this disorder when I was in medical assisting school a couple years ago. We had to submit a course project based on a disorder that we saw in our externship, and one of my classmates came back and discussed this because she was working in a peds office, and I thought it was really interesting and wanted to use this opportunity to learn more about it. So a little bit of history about phenylketonuria, or as I'll refer to it a lot as PKU. It's an inheritable disease. That comes from increased levels of phenylalanine in the bloodstream. As you know, phenylalanine is an amino acid that must be obtained through the diet, and it's the backbone of many proteins. It is found in all protein sources and even some artificial sweeteners. If you look at your bottle of like Diet Coke, for instance, you'll see that it says contains phenylketonuria. If you have phenylketonuria and it's left untreated, it will build up in the bloodstream and cause toxic levels. And if you're having toxic levels of something in your system, it can cause disorders and intellectual disabilities. Some physical effects of people who have this disorder. Some may go completely unnoticed, while others can be life-threatening, and it's pertinent that it's diagnosed in infants. It can also be diagnosed during pregnancy. That way, the developing fetus won't develop like heart defects and things like that. In infants, it's classic ketonuria, and it does not present with symptoms until a few months after birth. And then again, if it's left untreated, it can lead to brain damage. And then kids that usually have this disorder have light-colored hair and may have eczema or other skin conditions. It is a autosomal recessive condition, and so for this it means that both parents have to have a copy of the affected gene, which is chromosome 12q23.2, and so both of those mutated genes must be passed on. In an autosomal recessive condition, both parents donate a mutated copy of the gene to their child, and the parents may have no symptoms whatsoever, but when the child receives both copies, they present with the disorder. I have included my pedigree for this, just so you can kind of see how the disorder works. From my understanding, this means that a couple has a 1 in 4 chance of a child having phenylketonuria. The name of the gene disorder is the phenylalanine 4-hydroxylase, or referred to as PAH. And then again, that would be the gene symbol PAH on the 12q23.2. And then I've included the GenBank ascension number. Hopefully this whole thing is going to fit into my screen. I'm not the most tech savvy. Normal functioning PAH gene holds information to create the phenylalanine enzyme. And phenylalanine is a protein, like I said, or amino acid, that we must obtain through dietary intake. And the primary function is to convert phenylalanine into other amino acids. There's multiple mutations of this. You can read what I have written there, but usually it's through coding that it's mutated, it's either deleted or transcribed wrong or things like that. And then again, I go on to note that if it is mutated, that it will cause the condition in the person that will lead to brain damage and other things like that. Sorry, this last slide is just the CDS sequence, the amino acid sequence. I don't need to go over all of that, but you can just kind of see how it works. Here you have, the CDS length is genes 1 through 15 through 1473. Blood assays are the typical use for diagnosing this condition. It can be used in the parents as carrier testing or in prenatal. That's the best way to do it. It's also done in newborns. I think it's a heel stick, and they see if the infant has the disorder. It's not mandatory typically, but if the mother has the disease, and it is, that way the mother can follow the phenylalanine restrictive diet. Like I said, it's done typically in newborns, and it's pertinent to know for both the baby and the mother. I couldn't really find much information on the cost of the testing. I included a little information here, but it seems like there's a wide variety. You could do it as cheap as $1 or a couple $100s, but typically it's going to run through the hospital, and they'll test it and include that in your bill. I haven't really found any controversy with this. It seems like a fairly straightforward thing, but I'm sure as with everything, there's a little bit of controversy. My sources.